In this presentation, we will be solving for impedance and current in a series RLC circuit. So we have one resistor, one capacitor, and one inductor in series with a power source. One of the differences for a circuit that contains both capacitance and inductance is that those two values are 180 degrees difference. So how we're going to have to calculate the impedance and build the impedance triangle, there's a couple of different methods. We can look at this from the point of view that the resistance is going to remain the same and it has no effect. In previous circuits, we have looked at inductive reactance as going up. And in this case, we have an inductive reactance of 90 ohms. And capacitive reactance, we have 60 ohms of capacitive reactance. So we have two vectors that are 180 degrees different. So what we need to do is take the difference between those two and we can build a triangle from that direction. The 25 ohms of resistance is still the adjacent side of the triangle. And the result this time would be 30 ohms of reactance. Now, that reactance is in opposition to current flow, but is the difference between the capacitive reactance and the inductive reactance. Can build a triangle that way and solve using simple Pythagorean's theorem, which would be the square root of the resistance squared plus the reactance squared. Or you can use a modified version of Pythagorean's theorem and use the square root of r squared, because that number is not going to change, plus the difference of the inductive reactance and the capacitive reactance, and that value squared. Now, it does not make a difference just as long as whichever number is bigger, you're subtracting the smaller one from that. So you could place this in your calculator as the square root of 25 squared plus the difference of 90 ohms of inductive reactance minus the 60 ohms of capacitive reactance, and square that. Either using the first method that I showed you or the second, the modified version of Pythagorean's theorem, you will still end up with an impedance of 39.05 ohms. And that is a total opposition to current flow, and with it being a series circuit, that accomplishes building the impedance triangle. So now that we have the total opposition to current flow, we can use Ohm's law and solve for the total current, with the current being the same at all points in a series circuit and being a reference. We only have to solve for it once. So I total will be equal to E total divided by Z, which is the total opposition, or 120 volts divided by the 39.05 ohms of impedance. And in this circuit, we will have a total current flow of 3.07 amps.